Okay, let's see. Okay, we're live with this Friday's Wi-Fi videocast. Hey, Bryan.
It's not just Wi-Fi, it's just everything.
Everything, yeah. All right, we'll talk about everything that we can. So we wanted to start off talking about speed testing.
Cool.
Wi-Fi speed testing. So we've been doing a lot of it. We've been doing this forever, right? But with Wi-Fi 6, it's getting more interesting because these things are getting increasingly faster. They're approaching like gigabit speed now. But what is it realistic to expect as far as like speeds go when you're testing these different ways? Generally, when I get a new access point in, I'll do speed testing with Iperf. I actually use this implementation. It's called JPerf that puts up a nice graph. So it uses Iperf, but it puts the information in a graphical form. It's just like a front end for it. So I'll put a link to that. That's a pretty useful tool now. Before Wi-Fi 6, I could just run a single stream and pretty much max out the Wi-Fi. What I've noticed with Wi-Fi 6 is that I'll have to do multiple streams to get the maximum connection. So there's an option for in Iperf to run either a single stream or multiple streams. So I've been doing something like 5 streams to maximize out that throughput.
Yeah.
And of course, you want to have a station that's connected at faster than gigabit speeds to see if maybe you could get faster than gigabit under some circumstances. Which I have seen with my testing.
We run into this a lot. Let me see if I can speak. With line speed.
Yeah.
So, I don't know if you recall your 11AC testing versus your 11AX testing.
Yeah.
How close can you get to line speed? What I mean, what we always run into is, hey, I paid for 1 gigabit or 500 megabits per second with the ISP. I should be able to get 500 or 1 gigabit wireless speed.
Yeah,
that's the big one, especially with residential cases.
Yeah, so when you're selling Wi-Fi equipment, you're going to hear that a lot. You're like, oh, I'm paying for this, why am I not getting this? And if you have a wired station, like the station I'm on right now is wired, 10 gigabit, switched all the way to the internet, and then I have a 1 gigabit internet connection. So if I use Speedtest Net on this machine, I get close to a gigabit speed down. So I get 940 meg, right? Even then, it's not the full gigabit. So even wired, you still don't get the full because there's overhead with the router and things like that.
So wait, let's talk about that for a second. So your desktop, right?
Yeah.
So what connection on your desktop do you have?
So my desktop's connected into a switch with an SFP plus Twin-X cable, which is linked at 10 gigabits per second, right?
So 10 gig from your desktop to the switch.
To the switch, which is a multi-gig switch. So the access points that I'm plugging in there have 2.5 gig connections. All the current Wi-Fi 6, high-end access points do.
So your 10 gig connection is connected to a multi-gig switch or a 10 gig switch?
Multi-gig switch. Multi-gig.
Yeah, so 2.5 gig.
Yeah, but the uplinks are 10 gig on this switch that we're using. Yeah. So the desktop is connected to the switch at 10 gig. The access points are linked at 2.5. And then on the Wi-Fi side, if I look
wait a minute. What I wanted to talk about, though, is so you're talking about wired speed right now, right? So we get this question a lot. So what I kind of want to make prevalent to everybody is that your desktop is connected from your desktop to the switch. It's got a 10 gigabit connection to a 2.5 gig switch, which is connected to other switches that are multi-gig and 10 gig, right?
Yeah.
Really.
Yep.
And then that's to your ISP's modem, right?
Right. So my connection to my router, it's all 10 gig. Then the router is 1 gig to the ISP's modem. So So yeah, my connection's all 10 gig all the way through, and I'm still not getting the full gig. The most I get is maybe 940, which is really good, but pretty close.
And the testing that you're doing is internal to your network. It doesn't go out
right
beyond the ISPs.
Right. So when I do Wi-Fi speed testing, I use Iper. So it's internal to the network. So the speeds that you'll see, they're not relying on what the ISP is doing. But I'll also use Speedtest app or Speedtest.net to check the differences there, and Speedtest.net, it does do multiple connections, so it's connecting multiple servers. It's like multi-threaded. It's doing all this stuff, so it's actually a pretty good test, but it's still relying on your internet connection.
Speedtest.com, right?
Speedtest.com, Speedtest.net, yeah. So, I mean, that's what everyone uses. So, everyone that goes out and buys Wi-Fi, they're going to get the Speedtest.net app on their phone. They're going to test it and be like, wait, I'm not getting my speed, like you said. So what will you actually see? So, on my, I have a laptop here with the latest Wi-Fi 6 2x2 chipset from Intel, and I will connect to a 4x4 access point like the Ingenious ECW 230. I'll connect at 1.2 gig, data rate. That's what I'll see on the adapter that I'm connecting at.
So your wireless laptop will basically connect at a rate at 1.2 is what you're saying. 1.2 gigabit.
1.2 gigabit. So
the laptop has the ability to connect at 1.2 gigabit.
Right. Yep.
The thing to note about that is you have to understand that your clients, that rate that we're talking about, that 1.2 gigabit, every client is going to be connected at different rates because of the ability of the client.
Right.
So you have to keep that. You have to keep that in mind.
Yep.
You might connect at 680 megabits per second, or 700 megabits, or 300 megabits per second. So it really depends on the client that you're testing on. It has to wirelessly connect to an access point, so that the radio signal between the client device and the access point have to connect, right? So if there's no interference or it's a clean air, that negotiation rate is then established.
Yep.
And that negotiation rate could be as high as, like what you're saying, is 1.2, or it could be as low as 200.
200, exactly.
So you have to be really aware of that connection speed.
And on the iPhone, it won't tell you what that connection speed is, but it could be up to 1.2. And now that's at 5 feet away from the access point. So that's like the first place I'll test. You want to do a test close to the access point, get your maximum rate, and then kind of move your way out with obstacles in between and things like that. But what are they actually going to see? So in the real world, one of these Wi-Fi 6 access points, if you have a decent clean channel, 80 megahertz, make sure that you're set to 80 megahertz if you want speed. If you want to see fast speeds,
I want you to slow down a little bit because I think this is important because we get this a lot. Hey, I put in a 4x4 access point and I'm only seeing 200 megabits per second. And there's a lot around that. There's a lot to understand why you're getting the 200 megabits per second.
Right.
In regards to access points, it does, you have to be really careful because a lot of people test at the default settings, right? The default settings, meaning the way when you take that access point out of the box and you plug it in and you start testing it, whatever those settings are the default settings.
Right.
If you don't go in and modify those default settings, then you could be going slower than what the access point can do. Like, for example, our access points, cloud access points, specifically the cloud access points, out of the box, they're configured in a particular way, and they're configured in a way where you're going to have a lot of access points in one area, right? So, we might have auto channel initially. We'll have 20 megahertz wide channels on 2.4, 40 megahertz on 5 gigahertz, and so on. And the minimum bit rate's not set or anything like that. So it's set up out of the box that way.
Right.
Now, that is not the best setting for speed testing at all. Zero. You're not going to get maximum speed out of that.
Right.
Now, other brands or other vendors out there that will give you 20 megabit, specifically the widths of the channel or the important part, 20 on 2.4, typically that's what you always want to do because you have less channels there. But they'll go to 80 megahertz on the 5 gigahertz frequency band. So your tunnel is larger, so you can pass through more data. So that's a setup for better performance. Now, you were saying to me the other day, Ruckus does it even, in some cases, they even do it down to 20 megahertz on the 5 gigahertz.
Yeah.
Right?
Sometimes, so they may have a setting for maximum compatibility and maximum speed. So when you're shipping access points out for business use for schools, hotels, things like that, you kind of want maximum compatibility. No one's really going to be doing speed tests to see if you're getting your full internet connection on every single access point in those situations. You just want it to work once it's in there and not have a bunch of problems.
Yep. Yeah, so that's a really important thing. So with our product, with Ingenious product, we go into a lot of businesses and we go into a lot of residential. And so, the installer, the person putting the product in, has to understand that. Like, you have to change channel widths, for example.
Yep.
Or your radio configuration has to be right, depending on the environment. If it's residential, then you can have one configuration. If you're in a business, you're going to be configured in another way.
It's tough for those residential installers because, they're installing this new hardware. The customer paid for an internet connection. They want to see that full speed. So I feel it for them. But then once they leave, there could be problems if they leave it at the fastest possible configuration.
The interesting thing, right, is that if they never looked, unless they have major problems, right, if they're disconnected and things like that, or they weren't roaming properly, even with roaming within a home, if they never looked at the speed, they probably would not know. Right.
Because even the slowest speeds, if they're good, if they're not dropping, if you have a clear channel at 40 megahertz on 5 gigahertz, you're gonna have enough speed to stream 4K HD, everything. You're not gonna notice any problems as long as that's kind of what you want, because you want a solid connection, not just a fast one that you can do speed tests on, right? So that but people always want to see the fastest speed, so then we increased it to 80 megahertz or even 160 on some consumer type routers that I can't believe that runs anywhere well, unless you're in a lead room,
just so if anybody's watching, right? So when you go from 20 megahertz, we're talking about the channel widths on the frequency bands, and we're specifically talking about 5 gigahertz because 2.4 is really there are more IoT devices than anything, or maybe a very legacy client device. But on 5 gigahertz, we're talking about how wide the channel is, or how wide the channel is that you're using it for an access point. So you go 20, 40, 80, 160. If you go to 160 on 5 gigahertz today, you only have one channel to choose from, and you open yourself up for interference with your neighbors or other access points or other devices that are out there. When you go down to 80, you have 2 channels, and you have more choices with 80, but that's still not a lot. And then you can move down to 40, gives you more channels, and then 20, you can move down to even more channels to give you more flexibility in high interference areas, right?
Yeah. But in general, though, if you have things configured correctly, you can run 80 at 5 gigahertz.
Yeah, I run 80.
Yeah, most people are going to be able to run 80, but if you have DFS channels, you have 6 channels available with DFS now. Some APs don't have access to those DFS channels, then you're down to just a few channels. So what you want to do is have a spectrum analyzer like the YPRI around, look at what's in your area. Like if you're in a residential area or in an apartment building, something like that, you're going to see tons of networks all around. So you basically, either let your Wi-Fi system pick the channels or, statically pick a channel that looks good.
Yeah.
Sorry,
I didn't mean to sidetrack you. I
know no, that's good. That's good. We need to talk about that stuff because that's the difference. Now, when people are testing, like, what are they going to see? So with Wi-Fi 6, you're generally going to see about 650 meg if you have a clean 80 megahertz channel, right? So that's what you're going to see generally. Now, I've seen faster, but it's hard to maintain that because there's noise in the environment. Like I'm in a residential area. It's possible to get faster, but what you're going to see with the 4x4 access point and a 2x2 client is probably about 650 meg. That's what you're going to see at 80 megahertz. Now, you may not always see that because, again, if someone's stepping on that channel, you're going to get less. You could go down to 200 meg, But in my testing with Iperf and Speedtest Net, since my connection's gigabit now, I'm seeing about 650 meg with Wi-Fi 6.
But you're within like an eye shot of your access that you're communicating with.
Right. Again, that's the access point in the same room. So as you move out further, I have some speed tests on my blog. You can see I test in like 2 or 3 different positions in my house and see like what the differences are. And again, you got to do it with one access point. Make sure you're associating that. Pretty much shut everything else down. And then when you do that, though, you kind of invalidate the results because once you're up and running for real, you're gonna have 2 or 3 access points in every home probably.
Yeah.
And then
that's the case now, right?
Yeah. So most homes will have 2 or 3 Wi-Fi access points if they want full coverage. If it's like professional installation, right? They're gonna be wired in 2 or 3 access points. Then you're back down that 650 meg. Speed range, right? So I've seen gigabit speeds with just one access point going on in my house at 80 megahertz, but just not sustained, just like spiking.
I've never seen that.
Yeah, I have seen it, but it's you're not going to get that. What I'm trying to say is you're not going to get that all the time. You're going to probably see about 650 if you're lucky.
Yeah. So like based off your negotiation rate, right? Like so what I mean by that is when my laptop connects to my access point, it makes it connects at a negotiation rate.
Right.
That negotiation rate, how much of that negotiation rate would you see or get?
Usually about half. So
50%?
yeah, but with Wi-Fi 6, see, they always get a little more efficient, so it's always a little more than half. Like so if we said
60%.
we said 1.2 I'm connected at, and I'll get 650, maybe 700. So it's a little more than half. That's what you can expect.
Yeah.
Now, if there were any 4x4 Wi-Fi clients out there, I don't know if there are any client devices out yet. There may be Wi-Fi 6 4x4 clients. Once we start seeing those, we could, see faster speeds. But I'm not aware of anything that has it built in.
That's like that would be major laptop. That would be
it'd be like a business class laptop if there is one that has it. Maybe a MacBook Pro, a couple $1,000 MacBook.
Level.
Yeah. Not stuff
not
that you're going to see out there.
Laptop.
Yeah. Maybe some of the Macs have it. Probably not yet. They're probably still 2x2. But once we see, Wi-Fi 6E start hitting, we'll probably get over that gigabit for real.
Yeah, so Wi-Fi 6E, right? So it opens up 6 gigahertz. I know we talked about that in the last conversation, but remember we just talked about the 160 megahertz wide on 5 gigahertz?
Yeah.
Imagine if you could have 7 of those, right? It's 7, right, on 6E?
Yeah.
So when 6E, 6 gigahertz, you'll have 160 wide megahertz channels.
Yeah. Oh yeah, so it's gonna be huge. And it's gonna be new spectrum that nothing else is in yet. So
it'll be clear. Yeah.
It's gonna be clear. So it should be awesome if it goes off like we think.
But we saw that happening when we went from 2.4 to 5 gigahertz. When this all started, nobody was using 5 gigahertz. Nobody wanted to use 5 gigahertz. Well, I guess people wanted to use it, but manufacturers were not putting out client devices that were on 5 gigahertz. They were only putting them out on 2.4 gigahertz. So once like the, well, not even a cell phone at that point, once client devices started to support 5 gigahertz, then they're like, okay, and it started to ramp up more speed, that kind of thing. So
what about any kind of application analysis on access points too? Like I know, Ruckus has this sort of thing where it's like, analyzing what the traffic's doing and logging that. That can also slow down your speed a little bit because it has to push that data back up to the cloud or whatever.
So you're going to get overhead with your management systems. You will have overhead, so you have to kind of take that into account.
Yeah.
I know when we for our cloud solution, when we do application analysis, there's some overhead there. So you have to go, okay, how critical is it for me to understand like what applications are running on a network?
Yeah.
And if it's not super critical for you, maybe in a home scenario, I would turn it off.
Yep.
But if you want to keep it on, you have to understand that there's some overhead there.
Yeah.
And there's other features that are that have overhead for management devices. So that's another thing that we've seen is that, if you measure, if you're doing speed testing and you're speed testing on a managed device versus a non-managed device, there's going to be a difference there as well. So,
but not huge, and the benefit of that device being managed in that analysis data possibly. If you're a business, you really want that. It's not going to affect your speeds much at all, and it's giving you like a bunch of good information on your Wi-Fi network.
Yeah.
And good ways to keep it running, running well, not just, doing speed tests and getting the fastest speed everywhere,
Yeah. Where that's not important at all.
Yeah.
In a business setting, you're not looking at speed. I mean,
you are, but
if somebody's not efficient and not able to work, obviously, you are concerned, but you're not doing speed tests.
Yeah, the amount of overhead for these systems is very little compared to the advantage they provide for businesses. But like you said, at home, if you want to run speed tests like 10 times a day, then maybe turn it off so you'll make yourself feel better. but yeah, that's that. All right, so we talked about
just plug in at that point, right?
Yeah, plug in. If you want to see the fastest speeds, plug into the switch. All right, so we want to talk about a couple other things. What's a Bonjour gateway, Brian? Do you know?
I have no clue.
Okay, so basically, there's a lot of technologies or devices that are using like broadcasts, multicast to basically find these devices on your network. So things like Chromecast, Apple TVs, devices like that are basically advertising on the local subnet that they're there. If you have multiple VLANs or multiple subnets,
wait.
Go ahead.
Can you give other examples of that though? Like with Apple, for example.
So with Apple, I think it would be like printers, finding other computers on the subnet.
Apple TV.
Apple TV, yeah. I mean, really, Apple TV and Chromecast are the two big things you're seeing, as well as printers. Like to be able to see a printer. You need to have a Bonjour gateway, so across subnets. Okay, so if you have like I have an Apple AirPrint printer here. If I want it to show up on my iPhone, I have two subnets. I need to have a Bonjour gateway in between.
So let's make sure we clarify a little bit. So if you have an Apple printer, for example, within your network, that's, at your home, most likely you're going to be able to print to that, right?
If you have one subnet, So if most people are going to have a single subnet at home, they're going to connect up and they're going to see, I got a printer I can print to. Is this going to show up, right? That's basically it's using multicast DNS basically to do that. So it shows, and that's kind of how you're going to see like your Windows shares. When you open Windows networking, you see like all the computers pop up and all that stuff. Yeah. A lot of that stuff we try to block with layer 2 isolation.
I'm trying to slow you down.
Yeah. Yeah, so I'm just thinking right now. So
I know. So when you're in your local network, you'll be able to see these devices and you'll be able to print from your phone to your Apple printer, for example, right? Yep. But when you're in a larger, that's in your home, and you're all on the same network. And you can divide your network up within your home. But typically, you're on the same network. And what I mean by that, you're on the same subnet. That's what Jeff is talking about right now. But if you're in a larger scale business where you separate out networks, and the way you separate out networks are using VLANs. And so you have users on different VLANs, or they're separated from one another. So you might have staff on one, or sales on one VLAN, and you have your accounting on a different VLAN, and they're tied to different resources, for example. Right? So that's where you're separating out your traffic using VLANs.
Broadcast traffic, yeah.
Yeah, broadcast traffic. So when you want to share, like, an Apple printer, for example, that's where this comes into play, right?
Yeah, Apple printer, Sonos, AirPlay to a TV or to an Apple TV, things like that. So any of those services are going to be advertised by broadcast on your local subnet. So if you do have two VLANs and you want to be able to, for example, see those Chromecasts no matter which VLAN you're on. Maybe in a school or something like that, they could have Apple TVs that they're, but multiple subnets, and they want everybody to hit it. So then, in that case, they need that Bonjour gateway, which basically what it's doing is it's just advertising that, hey, on my subnet I have these devices. I have these devices on my subnet, and it's advertising it to the other VLANs.
Yep. Yeah, especially like in large deployments, like student housing or college or multifamily units, where you have all these people in different VLANs, but there's a common area where you want to share like a resource like an Apple TV.
Right.
How do all those people on different VLANs or different little networks or subnets, how do they see that Apple TV, for example?
Right, and it's like one way, so you can, like, if you have that common VLAN like you're talking about that has Apple TV on it, you can advertise, just that you can advertise that VLAN to the others, not the other way around. So if you have like any kind of resources you want to keep, secure on those other VLANs, they won't be able to see it. But it's basically just saying, okay, I've got an Apple TV on my subnet to all the other VLANs and subnets out there.
Yeah.
So you can, you could set up like a standalone server. A lot of times the access points will run the Bonjour gateway on the access point. There's different ways to do it. But if you're experiencing this kind of problem where you do have multiple subnets and you can't see your Chromecast or Sonos or whatever, you may want to, if it's a home network, you may just want to put all that stuff on the same subnet that and that'll fix your problem, because if Bonjour gateway isn't available, there's not going to be an easy way to do it for you.
So the Bonjour gateway allows like a Chromecast service or an Apple service to operate over multiple VLANs.
Exactly.
Right?
Exactly. Yeah.
So you're setting up policies to say, hey, the Chromecast service is on this VLAN, and I want it to communicate with these other VLANs, so everybody on those other VLANs can see that Chromecast device, basically, right?
Exactly. Yeah. So yeah, that's what it's used for. So if you're experiencing those problems, I'd look into it. I know like Apple makes one for Windows that you can run on the Windows PC to like see printers and things like that. But when we're talking about Wi-Fi, most likely it's going to run on the individual access points, because they're the ones that are touching those devices. Basically, those devices are connecting to the SSIDs and the access point, and so it can advertise across those different SSIDs and VLANs.
Right.
All right. So then one last thing. So want to talk about? I figured something out this week. Helped a customer out.
Oh yeah, that's right.
Yeah. So a lot of times we'll get calls that people they are configuring a new access point and they forgot what IP it's on, or they configured an IP address and it didn't take, and they can't get back into it anymore. And for a lot of the outdoor access points, it's hard to get to. Maybe up on a pole or something. Maybe hard to reset that access point to default. Right? We see this a lot.
Yep.
So.
Yeah.
now if you change the password and forgot the password, then you're gonna have to do a reset to default somewhere in that access point. You're gonna have to find a way to do it. Reset button.
Phone app, whatever it may be.
Yeah. So a lot of the new access points have they have a management Wi-Fi interface that you can connect to the phone app. So if that access point can't get on the wire or something, it will maybe advertise out like a SOS SSID that you can connect to with the phone app.
Yeah, it's a management SSID. So like any error that happens on the access point, you'll see the error on a management SSID, and
it'll pop up that you can connect to and reset it to default possibly.
Yep.
So yeah, that's one way of doing it. But let's say you forgot what IP address an access point is on. You can't get to it to reset, but you know the MAC address of that access point. Maybe you've got the box still, or you have a picture of the MAC address of the Ethernet MAC address of the Ethernet interface on the access point, right? So then you can open a DOS box on a Windows PC and use the ARP lowercase minus s command to set a new static IP to the MAC address of that access point. So basically just type ARP minus s, give it any IP address that's on the computer's subnet that you're on, and then type in the MAC address of the Ethernet address of the access point.
Not to put you on the spot.
Yeah.
Like, you share your screen and show that?
Not easily.
Not easily. Okay.
Not easily. Yeah. Maybe next week I'll figure that out. I don't want to.
Maybe you can put that in the comments of how to do that.
I will. I'll put this in the comments on how to do it. But if you just go to a DOS box and do ARP and just hit enter, it'll give you the help, and it actually shows an example in the help of how to do it.
Yep.
So it's pretty easy to do. So by using that ARP command, you can set that temporary IP address, access the access point, and then set back to whatever permanent address you want. Find out what address you had it set to, or change it to DHCP. This is something somehow I just thought of this because it comes up a lot, and we never. We're always like, oh, well, you can use the app or use this or use the reset button. We always tell them.
Yeah, we have all these different tools, but.
Yeah.
Where some customers get into like positions where they don't have access to these other tools. So what do you do?
Right, like the hardware reset button. That's the main tool that we'll tell people to do, and we tell them over and over. If they can't get to that hardware reset button for whatever reason, then this is a way to get that IP address back.
Right.
So.
That's a great tool. I've never used it, so.
Yeah, I'll put it in the comments so people can see. But All right, Brian. Anything else you want to talk about this week? Any plugs? Yeah. So I'm gonna put a link to your custom Porsche hats in the.
Oh, sweet.
in the comments in case anyone wants to check those out. Brian's like a big Porsche fan, so he's got those in there. I'd get one, but I'm into Corvettes, so.
Jeff's got the new Corvette.
Yeah. The new C8's pretty cool, but I can't be seen driving around in a Porsche hat. All right, man. So we'll end this one now, and please remember to like and subscribe for more help with Wi-Fi.